This video is on the greatest integer function and piecewise graphing. We're going to talk about the greatest integer function first. F of x is the greatest integer less than or equal to x. That's the greatest integer function. So int of x, or you may see it as this, where it kind of looks like an absolute value, but then it has little bottoms on both of the things. You may see it written like that some places. Essentially what it is you take whatever the number is, and then you always round down, so to speak, to the nearest integer, not the nearest integer, but the integer that's below it. So x is 2.1 here. I'm going to write 2 because that's below it. 3.9, the integer that's below it is 3. So in rounding, we would go up to 4, but we're essentially going down to 3. 0, 0 is going to be on the graph because you don't have to change it. It's equal to, less than or equal to. So then 1 is going to have 1. Negative 1/2, this is where it starts to get tricky. Negative 1/2 does not go up to 0, it goes down to negative 1. So when we see a problem like f, negative 1.1 or negative 11/10, we see the negative 1 and we may think that we just want to write negative 1, but we have to always go down to the integer, the greatest integer less than or equal to. So the nearest less than integer, less than or equal to integer. So that's going to be negative 2. So now I'm going to graph these things. 2.1 comma 2 is on the graph. 3.9, that's not 2. Sorry about that. 2.1 comma 2, 3.9 comma 3, 0, 0, 1, 1, negative 1/2, negative 1, negative 1.1, negative 2. These are all points, but that doesn't represent every point. So I'm just going to start plotting a lot of points. If I have 2.2, that's going to be at 2, 2.3, 2.4, and so on, all the way up until I get to 3. And then once I get to 3, I then start to go up here. So it's going to look something like this. So this is how the greatest integer function is graphed. That should be an open circle, open circle, open circle, open circle. And so this is the greatest integer function. The domain of the greatest integer function is all real numbers. The range of the greatest integer function is just the integers. So negative 3, negative 2, negative 1, 0, 1, 2, 3. It's the integers. And that should be a dot, dot, dot after that. So it's the integers. If I want to use my nerdy math notation, I use the z with the extra line. Evaluate the following using the greatest integer of 2x. So if I have f of 1.2, that's going to be the greatest integer of 2.4, which is 2. This one's going to be the greatest integer of 3.2. Oops. Which is 3. This is going to be the greatest, I keep doing that, the greatest integer of negative 3.6, which, remember, when we have a negative, we have to go even further down, so that's negative 4. And then this is negative 4.8's greatest integer, which is negative 5. That's the greatest integer function. When a function is defined by more than one equation, it's called a piecewise function. So we're going to go over piecewise functions. F of x in this case is 2 different lines. It is x plus 1 when x is less than or equal to 0. So when it's less than or equal to 0, it looks like this. And it's negative x when we are greater than 0. So I'll graph that in a different color. Notice greater than 0, so I have an open circle at the point 0, 0. And that's kind of how it works. So this question was easy to be able to just kind of graph like this. Sometimes it may benefit you to graph the entire line for some of these things and then just erase things that you don't want when it's over. So x plus 1, I could have graphed the entire x plus 1. I could have graphed the entire x plus 1, and I could have graphed the entire negative x, and then I could have been like, okay, x is less than or equal to 0, this one applies. So that means that I don't want anything that's bigger than 0 on this line. Negative x greater than, so I don't want anything over here. So that's another option for you in terms of like something that you can do if that will help you out. So the domain of this function is all real numbers, negative infinity to infinity. We don't have any x values that are not hit. The range, if I'm looking at the range of this function, if I look at the range of this function, that's this line kind of sweeping up. I hit everything. Even though there's a hole here, I still hit a value at negative 1, 0, so I'm still hitting that y value. And then it goes up to 1, and then after that, I don't hit anything else. So the range of this function is going to be negative infinity to 1. The x-intercept of this function, there is one x-intercept. There could be more, but there's one x-intercept, and it's at negative 1, 0. Notice that 0, 0 is an open circle. It's a hole. It doesn't. It has no value. The y-intercept is at 0, 1. This function is increasing. When we think about increasing, we're always thinking about as we go from left to right. So if I'm going left to right, my function is increasing on the red. So that means it's increasing from negative infinity to 0. And we will never put brackets for increasing and decreasing, because even though this is a closed circle, like it's not really increasing at that point. It stops at that point and then starts over. So we're always going to put parentheses here. And then this is decreasing from 0 to infinity. Problem 2, x squared. So I'm just going to graph the whole thing, y equals x squared, and then I'll erase what I don't want after that. So y equals x squared looks something like this. Doing this on a tablet where you're not actually looking at the screen is a little harder than it looks. So it looks something like that, but I'm only going to do negative 2 to 0. So I don't need anything past negative 2, 4, and I don't need the entire right side of the graph. And then y equals 1/2 x plus 2. I'm only going to graph what I need out of this. So 1/2 x plus 2 up 1 over 2, and I don't need to go any further. Now I do need an open circle here because it is an open circle. It's non-inclusive, and I also should have an open circle at 0 for my parabola because it's not inclusive there. So I now kind of have an understanding of what I need. Domain, it looks like if I was sweeping my domain and I'm going across here, it looks like I start hitting things at negative 2. At 0, I still do hit something on the purple line, and then I go to 2, but it doesn't hit anything. So my domain in this problem is negative 2 to 2. The range in this problem goes from 0, not inclusive, all the way up to 4, and there are no gaps in that. So 0 to 4. The x-intercept, there is none. This is a hole. The y-intercept, there is one at 0, 2. Increasing interval, remember, as we're going from left to right is what it is for increasing. That's 0 to 2. And decreasing, left to right, I'm going down on the black curve. So that's negative 2 to 0. Problem 3 on piecewise. Write a piecewise function that represents the following graph. So I have 3 parts to this. So g of x is an absolute value graph that has a vertex of -3, -5, and it looks like the increase rate is 1. So I'm going to say absolute value of x plus 3 minus 5. That looks like it goes from x equals -6 all the way to -2, and the -2 is included. Then I have this line. I can use point slope, but since it crosses the x-axis, it's probably, or the y-axis, it's probably easier to use slope-intercept form. So my slope is 2. So that would be 2x minus 3, and that goes from -2 to x all the way up to 1. So those are my x values that do that. And then this red curve over here looks like a parabola with the vertex at 1, 2, and like a slope, quote unquote, a value, I guess, of -1. So it's -1 times x minus 1 squared plus 2, and that looks like it goes from 1 to 3. So the domain of this function is -6, not inclusive, to 3 inclusive. The range of this function is from -7, not inclusive, all the way up to 2 inclusive. And there are no gaps in my range or my domain. So if I like swept across with that line, I would see that I had no gaps. Even though there's a hole here, notice there is a y value that meets it at that criteria. Same thing, the hole here, there is a y value that works with it. There is an x-intercept at, well, I have to actually find this x-intercept. So I substitute 0 in for g of x. So 0 equals -x minus 1 squared plus 2. So I subtract 2 and divide by -1 and take a square root. I get square root of 2 equals x minus 1, so plus or minus. So I would get 1 plus or minus the square root of 2 equals x. That would be how I solve this in algebra. But notice I'm only taking this side of the graph. If it got extended, I would also have one over here. But because it didn't get extended, I only have the right side of the graph. I'm only looking at this one, which means it's at 1 plus the square root of 2. That's my only x-intercept in this graph. The y-intercept is at -3. I'm increasing from -3 to -2. And from -2 to 1, and that's it. And then I'm decreasing from -6 to -3 and 1 to 3. So remember, that's from left to right. Piecewise function for number 4. The vertex of this one is at -3, -2, and it looks like my a value of the parabola is 1. So x plus 3 squared minus 2, and that's from -4 to 1. Then I have a horizontal line at 4, so y equals 4, and that's from, that should be a -1, and that's from -1 to 3, and then I have from 3 to infinity, so I would just say x is greater than 3. I have a line, and I'm probably just going to use kind of a version of point slope, so I don't have to think about it, but the slope is 2, and then the point that I'm going to use is 3, 3. So x minus 3 plus 3. The domain of this function is -4 to infinity. There are no gaps in my domain after that. I do have 2 holes, but there are values that are hit. The range goes from -3 all the way up to infinity, except there is a gap. So notice that from 2 to 3, there are no y values. So that means I have to say -3 to 2 union 3 to infinity. The x-intercept, once again, I'm going to have to solve this parabola and only take the right side. So I have x minus 3 squared minus 2 equals 0. Set y equal to 0, add 2, take the square root. I get x minus 3 equals the square root of 2, plus or minus. But I'm only going to take the positive side because it's the right side of the parabola. Then add 3, so x equals 3 plus root 2. So I have 3 plus root 2, comma 0. The y-intercept is at 4. This function is increasing from negative 3 to negative 1 and from 3 to infinity. It is decreasing from negative 4 to negative 3. Remember, we're always looking from left to right. And then it is constant from negative 1 to 3. One other thing you should note is that whatever is in your domain, there should be something either increasing, decreasing, or constant for all values in your domain unless there's some sort of jump. So, for example, negative 1's in my domain. I see negative 1, but I have parentheses for both of them. So unless there's some sort of jump or gap or something, or some kind of different weird function, then you're going to have a missing spot in the interval there. But otherwise, everything that's in your domain should be showing up somewhere in your increasing, decreasing, or constant intervals.